Let's take a look at I. In I, we've got 25x cubed equals 64x. Now, as a reminder, if we have anything bigger than just an x in an equation, we want to get everything on one side so that the other side equals 0. So the problem with this equation as is the 64x needs to go on the other side. So the only way to move that is to subtract a 64x from both sides. However, now the 25x cubed and the minus 64x are now on the same side. The question becomes, what's on the other side? Well, we canceled everything out, but there's still something there. There is a 0 there as kind of like a placeholder. So again, looking at a problem, what we should notice is that the highest exponent is a 3 again, which means I should be getting 3 solutions. I should also zoom out a little bit and notice that both of the pieces, I've got an x cubed and an x, both pieces have at least one x. So I can factor out a greatest common factor of x. So pulling out an x from the 25x cubed will leave me now with a 25x squared. Pulling out the x from the negative 64x means that x will be gone. So I'll have just the negative 64. And don't forget this was an equation, so it still needs to remain equal to 0. So continuing along, we want to not lose that x that we just found. That's a GCF, so I'm going to carry that down. However, what's left here, the 25x squared minus 64, is a binomial. If it factors, it squares or cubes. Now, because of the exponent being a 2, we know it's a square. What's squared in this first piece is, well, we've got 25x squared is a 5 and an x. What's squared to get the 64 is an 8. So what that means is that this will factor out as 2 pieces of 5x and an 8 in both. But remember, with a difference of squares, we can only do this because it's a difference. A minus sign is we end up with 1 being a plus and 1 being a minus. Then it will equal 0, and we are almost done here. Continuing along, the next thing that we need to do is take each of our pieces and set them equal to 0. Okay, starting with each of our pieces, let's start out with the x first, which means that we'll just start out with an x equals 0, which is already done. Then we move on to our second piece. The 5x plus 8 could equal 0 as well. Or the last piece, the 5x minus 8 could also equal 0. Now, like we said, the first equation is already done. X equals 0 is one option. The other two we need to start solving. So in the first one, we can subtract 8 from both sides, which will give us that 5x equals negative 8. Then we can divide both sides by a 5 to get the x by itself, which will give us a solution of x equals negative 8/5. And we just have one more equation to deal with. On the last equation, we're going to start by doing the opposite. We'll add 8 to both sides, which will get us that 5x equals positive 8. We'll still do the same next step. We'll divide both sides by 5, which will get us that x equals positive 8/5. So again, we're getting 3 answers. X equals 0 is 1. X equals negative 8/5, and x equals positive 8/5. And again, we were getting 3 answers because our highest exponent was cubed on the original problem. Now let's look at J. In J, let's see, we've got 3x plus 8 times x minus 7 equals 6x plus 16. So it looks like we have something good going on because the problem is already factored. But, and this is a big but, we only want it factored if it equals 0. So this is kind of a good example of coming in on a problem partway through where you're like, uh-oh, somebody made a mistake. they factored too early. They factored before everything equaled 0. So I need to undo their mistake, and I need to undo the factoring. What does that mean I need to do? It means I actually need to take these two and FOIL it out. I need to undo the mistake. So let's FOIL first. So I'll start by multiplying out the 3x, which will get me a 3x squared, a negative 21x, a positive 8x, and let's see, a negative 56. And the other side hasn't changed. We're just FOILing right now. Now we can continue after FOILing by combining like terms. We've got a negative 21x and a positive 8x in the middle. That can be combined. The 3x squared at the front will stay the same. The middle, when we combine or add like terms, the negative 21x plus the 8x will give us negative 13x. And the last piece, the negative 56, will stay the same. And we haven't done anything with the other side. Just like all the problems before this, the problem is that it doesn't equal 0. So I need it to equal 0. So I need to get rid of two things. I need to get rid of the 6x over here and the positive 16. One thing at a time. Getting rid of the 6x means I'm going to subtract a 6x from both sides. And let's see, we've got a positive 16, so yeah, we'll do the opposite. We'll subtract 16 from both sides. And let's see what we've got now. Now we've got a 3x squared minus 19x minus 72 equals 0. Now in order to factor this one, again, we've got three terms with nothing in common. We're looking at AC method. So A, B, and C. So A times C is 3 times negative 72, which is negative 216. And we're looking for two factors of negative 216. That add up to a negative 19 here in the middle. And the two numbers that'll do this would be a negative 27 and a positive 8. We'll add up to negative 19, but we'll also multiply together to give you the negative 216. So what this would do is let me break this down, this middle piece down, into a negative 27x. So we've got a negative 27 and a positive 8x. The other pieces, the 3x squared and the negative 72 at the end would stay the same. And of course the equals 0 is going to get carried down to the bottom, so don't forget that this is actually an equation. But once I have four terms, I can do grouping. So let's try doing grouping. So grouping the first two, notice that they're both divisible by 3 and have an x, which will leave us with an x minus 9. Then the second two, grouping those two, notice we've got a plus sign in front, and they're both divisible by 8, which will leave us with an x minus 9, which means I can now factor out a matching x minus 9 from both pieces. Factoring out that matching x minus 9 will leave us with another factor of 3x plus 8. So my factoring is x minus 9 times 3x plus 8. Now you're still not done. This is still an equation. You still have to take both pieces and set them equal to 0. So I still have to take the x minus 9 and set that equal to 0, and the 3x plus 8 and set that equal to 0. And solving that equation on the first one would start with by adding 9 to both sides, which will give me x equals 9 as one solution. And on the second equation, we'd start off by subtracting 8 on both sides, which will end up giving me, let's see, 3x equals negative 8. Then we can divide both sides by 3. And what will happen next is that will give me that x equals negative 8/3. And we're done. So we end up with two solutions. x equals 9, and x equals negative 8/3. So every single problem in Chapter 5 requires factoring. It's just whether or not you stop with the factoring and you actually need to solve it because it's equal to 0. Finding some solutions for x, like x equals 2 or x equals 9 and negative 8/3, like in this one. Now, I would say Chapter 5 is the most important chapter in this entire course, because just to give you a preview of what's going to happen on Test 4. On Test 4, in Chapter 6, we're going to use all of this factoring. So it's super, super important that you spend the time now learning the factoring so that you're not completely overwhelmed in Chapter 6. The goal with Chapter 6 is going to be reducing fractions, but our fractions are going to look a little bit crazy here. They're going to look something like x squared minus 3x plus 2 over x squared minus 1. And reducing a fraction here is going to mean that you have to factor. So you'll have to know how to do this right off the top of your head. And on the top one, you'll sit here and say, oh, I need to do AC method. And you'll do that. And once you're done with AC method, you'll come up with x minus 2 times x minus 1. And then on the bottom, you'll have to do a whole nother set of factoring. You'll have to look at x squared minus 1, which is a difference of 2 squares, and you'll have to factor that as an x plus 1 and an x minus 1. And an x minus 1. And then what you'll have to say is, oh, wow, look, and I got an identical factor of x minus 1 on the top and the bottom. If that happens, that's how you reduce. You cancel a common factor that's identical from the top and the bottom, which will leave you with just the x minus 2 on the top and the x plus 1 on the bottom, and that will be considered our final answer. So every single problem in Chapter 6 has to deal with fractions. So what do you have to make sure that all of our fractions are? Reduced, which is going to mean that we have to make sure that they have been factored properly, and then anything has to be canceled that matches as an identical factor. So you have to be very comfortable with your factoring, and if you plan on taking any other math courses, you really do need to be comfortable with factoring. It's not going anywhere.